welcome to another one of our introductory videos relating to temperature metrology. In this video we're going to ask the question, what is a thermometry bridge? And then we'll introduce the Isotech MicroK thermometry bridges. So what is a thermometry bridge? Well, a thermometry bridge is the best way to measure the resistance of a standard platinum resistance thermometer in the calibration laboratory. And laboratories will use bridges rather than DVMs or precision thermometers because they offer ratiometric measurements, and with that greater accuracy and the ability to see very small resistance changes. So with a precision thermometer, very simplistically, they work by passing a known constant current through the resistance, through the platinum wire. And then we measure the voltage, and then from measuring the voltage we can determine the resistance, and from the resistance temperature. And the limitation of this type of design is if there's changes in the gain and the amplifier, if there are any thermal offsets, as things change it compromises the performance. And with a precision thermometer at best we might get an accuracy of a few parts per million. So good, but not good enough if we want to make the very best measurements we can. So bridges work differently. We compare one resistance to another. By measuring the ratio of an unknown resistor to a known resistance, we get a lot of benefits. The gain errors will drop out, other things will disappear, and we're able to make measurements much better than 1 part per million, down to perhaps 20 parts per billion, or maybe even slightly better. So why are they called bridges? Well, traditionally it was a Wheatstone bridge which was used. Wheatstone bridges aren't really used in thermometry. AC bridges became very popular and the circuit's slightly different. But these are the elementary circuits of this bridge which allows the ratio measurement. So, as I said, measuring ratio's got advantages. We can get better performance than can be achieved with a DVM or precision thermometer that measure the voltage developed across the resistance for known current. Bridges measure this ratio. So we have a standard resistor, and we might keep that at a constant temperature to have a calibration certificate, and we can compare the unknown resistance of the SPRT to the known resistance of the standard resistor. And then if we measure the ratio, multiply that by the resistance value of the standard resistor, we get the resistance of the SPRT. The older bridges could only display ratio. You'd often see those in the laboratory with a number shown. But newer thermometry bridges, they can compute and display temperature directly. So inside the bridge there's a database containing the value of the standard resistors, probe coefficients, and a modern bridge can display temperature as well as ratio. So in the second part now I want to introduce Isotech thermometry bridges, the MicroK range. Now our first models were intended for secondary laboratories, and they were introduced in 2006. At that time the performance was 0.4 or 0.8 ppm. They were very well received and the sales quickly grew. In 2010 we introduced higher specification models, and we used a new technique of parallel analog processing which was able to reduce the noise to new performance levels. And since we introduced these models, many of the national metrology institutes around the world have been using MicroK, replacing older bridges that had become unreliable. And we did receive the Queen's Award for Enterprise, the innovation category, for the development of MicroK. So we have different models. With a thermometry bridge we can make these precision measurements with an SPRT, but the MicroK can also measure thermocouple and thermistors. We've got 3 channels, and it's widely seen as being the best bridge for SPRTs. So our higher performing models, MicroK Gold 17125, typical clients for those are National Metrology Institutes and research. We can get an accuracy of 30 parts per billion over the whole range, better at specific ratio values. And then we've got more affordable models which are commonly used in commercial calibration laboratories, oceanographic, many applications. The sales are a lot larger. The performance is still very good, sort of 250 or 500 parts per billion, but the costs for these models, they're much more affordable than the primary models. All the Isotech MicroK models can be expanded with the micro scanner. You can add a maximum of a further 90 channels. We figured more than anyone would ever need, but we've got one client using 90 channels. And each of those channels can be individually programmed. You can configure an individual keep warm current, so there's always a constant current flowing through the SPRT. And you can configure the channel uniquely for the sensor type, the number of measurements per sample, units. Each channel can be individually configured. And we believe our micro is very special, and I'd like to tell you about 3 key advantages. One is performance. We are confident that we have the world's most accurate thermometer bridges. An independent evaluation at NMIs does demonstrate the superior performance of the MicroK models. And if you ask us, we can steer you towards some of those reports. Also, we've got performance with value. The higher end MicroK models are much more affordable than competing models. That's made possible with a new type of A to D converter. That helps deliver the distinguishing performance of the MicroK, and we licensed that technology from the National Physical Laboratory in the UK. Second thing about the MicroK, which we're very proud of, is completely drift-free, which makes it unique. So in ratio measurements, all the models of the MicroK are drift-free. That's because we've got a substitution topology, and we've got papers on that which we can share with you. So AC bridges, inside an AC bridge there are little potentiometers which you can adjust the filters and things. They move over time and need recalibration. Other modern bridges might have self-calibration, but the MicroK is by design drift-free, where there's no calibration in terms of the ratio accuracy of the MicroK. It's just something that comes from the design of the instruments, and there were no adjustments in software or hardware. And third advantage of the MicroK, we wanted to support all the thermometer types used in a calibration laboratory. So at the design stage, we decided we'd include voltage measurements so that we can measure thermocouples as well as SPRTs, PRTs and thermistors. So MicroK is easy to use. It's operated from a large touchscreen display. You can plug in by USB, a mouse and or a keyboard. That makes data entry easier. And all the MicroK models have built-in data logging. Let's take a walk through on how we might measure ratio measurement with an SPRT. Very simple, connect the SPRT, choose the range, choose the reference resistor, set ratio, and we've got optional values for the statistics. Let's see how that looks. So I've got a default PRT, don't need any conversion here. I want the 125 ohm range at 1 milliamp. I'm going to use the internal 100 ohm reference resistor. So here for units I just select RT over RS and we're good to go. MicroK Gold 17125 is just 2 ranges, 125 millivolts and 500 millivolts. MicroK Gold also has a 2.5 volt range. And the MicroK will automatically set the range as we set those values. In my example I had 125 ohms at 1 milliamp. So the MicroK sets the range appropriately automatically, making life easy for us. Let's see how we make a temperature measurement. It's pretty much the same as before, but now we need to add the SPRT calibration coefficients to the MicroK's database, and then we can select temperature, and the MicroK will compute the temperature from the stored coefficients. So from the calibration certificate for the SPRT, we need to take the coefficient, and we need a recent value for the resistance of the SPRT at the water dribble point. So the number of coefficients we need will vary with the temperature range. This chart here shows the different coefficients for the different ITS-90 sub-ranges. But in this example, we're going to go from the water dribble point to the freezing point of indium. And we just need a single coefficient, A, and the water dribble point resistance of the SPRT. So I can take those from my calibration certificate and pop those into the MicroK. So select Edit Thermometers, password protected, the default password's 1234. We can of course change that to our own value in the settings. And now I can add a new SPRT to the database. So in the fields here I can put the thermometer name. In this case I'll just put 909 example. There's no limit to the number of SPRTs we can store. Now I can put in the manufacturer's name. You don't have to, but it's a nice touch. The 909 is our secondary SPRT, so let's type in Isotech in here. And of course we want the serial number, the unique serial number for the thermometer. If I put the calibration due date in, I can get the MicroK to tell me when the SPRT needs to be recalibrated. It doesn't affect the calculation, of course, but it's good housekeeping. I like to do that. Now for the conversion, I'll choose ITS 90, go for coefficients, and I just need to put the A value in here, which is from our calibration certificate. Once I've got that value in, I'll also put in the water jug point value. If I was using a wider temperature range, I'd have more coefficients to enter. As I said in this example, we just need the single one here, and then the resistance of the SPRT at the water jug point value. And that's it, we're good to go. I'm going to put in the minimum maximum temperatures here. This doesn't affect the calculation again, but if the thermometer exceeds the temperature range that I put in here, I'll get a message, and I might like that, to get a message if the SPRT has been hotter or colder than I expected it to be. So now I've stored that SPRT into the database. So what I need to do is to go into the settings here and choose the thermometer. So now I can go into the database. Here's all the thermometers I've got. Here's my example, and I can now set my units to degrees C. I need to choose which reference resistor. I'm going to use the internal 100 ohm. So just changing this to degrees C from ratio. And now I'm good to go. I go to the single view, I can get my temperature value, and that graph will update over time. So very easy to use. We can choose between single and multi-view. In single view we just see one channel, and then on the multi-view we can see 3 channels. If I've got the scanner connected, the channel 3 position will update with the most recent channel. And here you can see the settings. So it's a simple to use instrument despite its complexity. We've got more video walkthroughs on YouTube showing various things. So if you're using the MicroK or you want to see how it works, do take a look at those. It's the same sort of thing, just a video walkthrough of using the MicroK. It's easy to use with remote operation as well. It's often easiest to use the inbuilt temperature logger and just export the data on USB, or you can operate the MicroK remotely. MicroK Gold 17125 of Ethernet, as well as IEEE, RS232 and USB connections. MicroK 250 and 500 don't have Ethernet, but they do have IEEE, GPIB, RS232 and USB. And with the MicroK Gold 17125, it's nice that we can use a remote display. So let me show you how that works. There's a little utility that will connect to the MicroK over the network, and then I can operate the MicroK remotely from the desktop PC. It's just logging in, and now you can see it's pulled up the screen from the MicroK, and I can operate the MicroK from the desktop PC. Just need some simple downloads, and the links are shown. So the MicroK interfaces all the models. I've got serial RS232, IEEE 488 and USB host. You can communicate with the MicroK using simple Skippy style commands. You can type those into a terminal program, and our own software, Cal Notepad, iCal Easy Log can be used to communicate with the instruments. Some commonly asked questions: what about the reference resistors? If I'm going to measure the resistance ratio of an SPRT, how should I select the reference resistor? Well, let's look at some examples. First example, primary metrology. So here I might want to measure the temperature of a fixed point cell, or measure the resistance of an SPRT in a fixed point cell. So our measurement accuracy will come from the uncertainty of the bridge and the uncertainty of the reference resistor. So for primary metrology, it's usual to select an external reference resistor, the highest quality resistors we can find. They can be calibrated to uncertainty of around 50 parts per billion, the temperature maybe 12.5 microK. And I want to temperature control that reference resistor. So that's the example for primary metrology. What value should it be? With the microK in general, we would say a value equal to the highest resistance that we measured. So for a 25 ohm SPRT, if we take that to the aluminium point at 660, that's equivalent to about 85 ohms. So we could select a 100 ohm reference resistor. In my second example here, I'm thinking about calibrating a resistance thermometer against an SPRT in an oil bath. So here no reference resistor is needed, because we can measure the ratio between the two resistance thermometers. So we can directly compare one thermometer to the standard thermometer. So I don't need a reference resistor in this case. And then the third example is using the internal reference resistors. The MicroK has a range of internal resistors. They're useful for many applications, but you wouldn't use those for primary metrology, like calibrating a fixed point cell or calibrating an SPRT to the lowest uncertainties. And if these are being used to make measurements, the resistors will need recalibration. So the MicroK's drift-free and ratio measurement, but the internal standards will need calibrating perhaps once a year. We've got more information about that on the FAQ link. So these reference resistors, other primary bridges, may not have internal references. If you visit labs with old AC bridges in the past, you would see a little pile of external resistors. They use a bulk foil resistor, very good quality, but they're not useful for primary calibration. But rather than have those external devices, we built them into all our MicroK models to make the Micro easier to use and more flexible. But finally, we're here to help. We believe we're the best thermometry bridges for SPRTs. We really enjoy discussing applications and thinking about how bridges can be used. So if you've got any questions at all, please do get in touch. We'd be delighted to help. As always, don't forget to subscribe to our YouTube channel so you'll be kept up to date with new videos as they become published. Thank you.